It's gonna be kind of a day and a half, but yeah, kind of a 2 day, but more like a day and a half. What's it called when all three sides of a triangle are the same? Equilateral. What's it called when two sides of the triangle are the same? Isosceles. And on an isosceles, you remember what these are called?
Legs.
Legs. And the not leg is called base. And they call that the vertex angle, and these are the base angles. The base angles are opposite, across from the legs. Okay, and what's it called if there's no equal sides? What's it called if there's no equal sides?
Scalene.
Scalene. Scalene. Okay, now what if all the angles are less than 90? What kind of triangle is that? Acute. All three angles are acute, the triangle is acute. What if there's one 90-degree angle? It's called a what triangle? A right triangle. If there's one angle bigger than 90, it's called an
Isosceles.
one angle bigger than 90. It's called a what? Obtuse. Okay, so you can name a triangle, guys. You can name a triangle based on the angles and based on the sides. Acute, obtuse, right. Equilateral, isosceles, or scaling. In a right triangle, what are the two sides next to the right angle called? These two legs. And the long side is called the hypotenuse. Hypotenuse. All right. Now, number one, based on the angles, what kind of triangle is number one? Right. Because it has one right angle. Based on the sides, what kind of triangle is number one? Isosceles. Because it has two equal sides. If you have to look this up, this was like the first lesson in the chapter. It's probably like 30, 40 pages ago. But it has all that stuff in there. Okay, on number 3, it says, use the figure in exercise 1 to name the following. A, the legs. So, number 1 is both a right and an acute, right and an isosceles triangle. So, which side are the legs?
Y, Z, and Y, X.
Yeah, I should have labeled it first. Z, Y, X. Yeah, he said Y, Z, and Y, X. In the right triangle, these are the legs because they're around the 90-degree angle. In the isosceles triangle, these are the equal sides, so they're the legs as well. Okay, this is right and isosceles, so they're the legs on the right, they're the legs on the isosceles. So Z, Y, Y, X. And then B says, what's the vertex angle?
Y.
Right. The vertex angle is the angle between, so on my drawing earlier it looked like this. This was the vertex angle. But it's always between the two legs, the two congruent sides. So angle Y is the vertex angle. C says, what's the base?
X, Y, X.
No. So the base is, if you're looking at it as an isosceles triangle, the base side is the side that's not the legs. So not these. So that would be, yes, the ZX.
Wait, so why are we looking at it at an isosceles instead of a right?
It's both. It's isosceles and it's right. So if they ask, on an isosceles triangle, or if it's just a right triangle, none of these are called the base necessarily. So, but on an isosceles, the base is the not congruent sides.
Okay.
It's a little confusing because it's both. D, the hypotenuse. So if you look at it as a right triangle, which side is the hypotenuse?
ZX.
Also ZX. The big side, it's across from 90. Number 5. All right. Which triangle is congruent to number 5? Which one looks like number 5?
A.
C. Yeah, if you look at it, it's a little bit lopsided. It's not perfect like A is. But yeah, it is C. All right. Number 7, cab. TRS. Okay, number 7 says name the congruent corresponding parts if these two triangles are congruent. So how many congruent parts should there be between two triangles that are congruent? 6. Remember this? There's 3 sides that were congruent and 3 angles that are congruent. You don't really need a picture like triangle CAB. You don't really need the picture to figure this out. You can just look right here. There's an angle C, angle A, angle B. But angle C is going to be congruent to angle T. They put it in order. So angle C is congruent to angle T. Angle A is congruent to angle R. Okay, and then how do we label the sides? Well, there's like a CA, yeah, there's like a CA, A, B, B, C. CA is going to be congruent to TR. And there's AB and RS. And what am I missing?
BC.
Yeah, BC, that's a side. And ST. Oh. You've been waiting this whole time? How'd you guys, was it Thursday you guys went to the college?
We got a 4-foot wing. They
Yeah,
didn't,
there
they
seemed-
didn't respond.
No.
You mean join?
Join, yeah.
Same difference.
So yeah.
Honestly. Yeah, what she said.
They were intimidated by you guys, obviously.
I would make them intimidated. I will go up there and.
Okay, on number 9, how many congruent statements are required to show that triangles are congruent using the definition of congruent triangles? So this kind of is referring back to number 7. By the definition of congruent triangles, all 6 of these should be congruent, so the answer is 6. Oh. I dropped in my flip. Okay, we're not doing 10 and 11, so 12, 13. 13. Did I draw it right? No, pretty much. Oh. 4x plus 15, 7x plus 6. All right. So on 13 it says find angle B. So that is this one right here, angle B. If angle A is 59 degrees. Now if you look in that picture, there's something already up here on angle A. So anyway, this must equal 59 degrees. And we're supposed to find this angle over here. So how can we use this fact to help us? What can we do with this?
We can do algebra and subtract 15 from 59.
Okay, we can do algebra and figure out what x is at least. 4x plus 15 is 59. Okay, how does that help us?
You plug in extra 11.
Yeah. Now, if I plug it in here, what am I going to get?
44.
59.
Right.
44 plus 15 is 59. We already know this angle is 59. We did, darn it, I want to get rid of that. Anyways, but it can help us find this angle, right? So 7 times 11
77.
plus 6,
Wait,
83. So let's just throw that one out and put an 83 right there. Okay. We'll just do that. So how do I get over here though? If this is 83, how does that help?
So you add the two numbers, and then you can subtract that from 180, and then that'll find the third.
Close, not quite, no. 83 is an exterior angle, it's not an angle in the triangle.
So the one on the inside just has to equal 180 with 83.
Right. These two together make 180.
So you can subtract 180.
Okay, yes, 180 minus 83 is 97. Now we got two angles in the triangle. So 59, 97, how do I find the third? What do I know about these three angles? They add up to 180. So 180 minus these two, or 180 minus 59 plus 97 would do it. I don't suppose anybody remembers the other trick, do they? Probably not. This is a different chapter. We had exterior angle theorem. If 83 should equal the sum of these two remote interior angles, like this plus this should equal 83. So 83 minus 59 would also give you the answer, or this is fine. But anyway, either way it comes out as 24 degrees. Alrighty, 15 is a bit of a doozy. Let me see if I can draw it better than I did in the other class. Let's see if I can do it. Is that what it looks like? Yeah, so I nailed it. Oh, I put the marks in the wrong spot. This one's not there. Oh no. There we go. No. 1, 2, 3, 4, 5, 6, 7. There. Okay, now that's right. Okay, 15 is like the hard version of number 14. 14 is not near as complicated. What makes 15 hard mostly is that they don't put numbers in here. The directions just say angle 1 equals x degrees. So yeah, I'll just put that right there. And we're supposed to find all these other angles. So we need like angle 2, angle 3, all these. Okay, so if this angle out here, this exterior angle is x, how would I find this angle 2 right here? What would I do normally? I need to go back here. If this is 83, how did we find this? We did 180 minus this to get this, right? So if this is x, this is what? 180 minus x. Ooh, I wonder if I drew it wrong in the other class and that's why it was harder. I think I put this mark in the wrong spot in the other class too. I'm gonna put it up there instead of right there. Whoopsie. Alright, anyway, doesn't matter. Okay, if this is, so what kind of triangle is this guy over here on the right? No, it's a isosceles. Okay, the cube part doesn't really matter right now, but if these two are equal, these two sides, what else do I know about the angles? Which angles? Which angles are equal?
Is it one supposed to be?
Angle 2 and 3.
What are X's?
Yeah, I replaced one with x. Huh?
Angle 2 and 3 are equal.
2 and 3 are the same. These are the equal sides. These are the base angles. They're opposite the equal sides. So if 2 is 180 minus x, what's 3? Alright. Do we want to do 7 now or later? I guess save it to the end. 7's kind of a little more work. Okay, if 3 is 180 minus x, how do I find angle 4? The exact same trick that we used up here, right? These are a linear pair, these are a linear pair, they should both add up to 180. So, what did we do to find angle 2? We did 180 minus this. So to find angle 4, we could do 180 minus angle 3. And angle 3 is that. So 180 minus 180 minus x. What's wrong with saying?
He's just so goofy. Yeah. You could hear all their conversations.
Yep.
That's crazy.
Okay, so when there's a minus, when you're subtracting like this, you have to subtract both of these. So it's kind of like 180 minus 180, and that just goes away, you know? But it's also minus minus x. So what's minus minus x? Plus x. So it's just x for an angle 4. All right, the last 3, a little bit tricky. Any bright ideas? Okay, what kind of triangle is this over here? Isosceles again, another isosceles. So, what do I know about this triangle?
5 and 6 are
Okay. The base angles are 5 and 6. These would be the congruent ones. Unfortunately, all we have right now is that this is X up here. So how do I find 5 and 6? How would I do that normally? When you go back in time. For some reason when you put X's in there, people don't get it, but when you put numbers in there, people do. And it's just how it is, I guess. So if this was an isosceles triangle and this was, what the? No.
I don't know. Well, I guess we have to be done with math.
Too bad.
I never fear. There's always a way.
Oh, when there's a way.
Don't even finish that.
Okay, that's a blank piece of paper.
Don't finish that.
I'm guessing it's the
It's the
second.
most
I had the red
overrated
one.
quote of the company.
No, I named new page. I think it might be this. Well, that does say 20. No, let's see, is this date right? Friday?
It's the 20.
Yeah.
Yeah, it's very-
And the time is right. Normally that's messed up. Pretty sure it's not on this page. I think it might have just,
Watch me be right.
this was today's, but I don't think I put it on.
Wow. Yeah, it's up there, right?
No, this is the other class.
Oh.
Where'd it go?
Keeps going.
Yeah, that was the other class. See how I marked the wrong side right there? Yeah. I guess we'll start from where were we? Where were we? No.
We were on angle 5.
I want to draw that again. Still not loading. Okay, go away. Okay, well, we don't need all this stuff. Right. We need some of it. Okay, so this was X, and we were trying to find these two. And I was talking about this triangle, and this is 50. So if this is 50, how do I find these two guys?
You would do 180 minus 50, and then you would divide that by 2.
Right. Well, these have to add up to 180. So if I do 180 take away 50, that leaves 130 for these two. So after you subtract this, you have to divide this by 2. So if this is X, how do I find these two?
You do 180 minus or divide by 2.
180 minus X, and then that has to be split up between those two, so this divided by 2. Now, you can't just divide one of these by 2, they're really both divided by 2, so it doesn't really simplify very well, so we're just going to leave it like that. What were these angles called down here? 5 and 6. Okay, so over here we had some angles, right? Hopefully you guys got them down. But basically, 5 and 6 are the same thing, right? So they're both this thing. 180 minus X over 2. Oh, great. Okay, I kind of need this. What was up here?
2, 3, 7. 2, 3.
No, what was 2 and 3? 180 minus 6. Okay. This one we said was 180 minus X. This was 180 minus X. So how am I going to find angle 7? Okay. These three have to add up to 180. So 180 minus these two would give us this. So one way to write it is 180 minus 2 times 180 minus X. Or you could add these together and subtract it from 180. But what do? We distribute that. So it's, you guys know what 2 times 180 is?
360.
360, and negative 2 times negative X is plus 2X. 180 minus 360 is negative 180. So this is like 2X minus 180. Anyway, that was the last one. Okay, so on 14, it's similar ideas, but they're all numbers, so it's a little less confusing. So if you have 132 out there on the right, how would you find angle 1? 180 minus 132. And what do we know about angle 1 and angle 2?
They have to be the same.
They're the same because it's an isosceles triangle and they're base angles. What do we know about angle 2 and angle 3? They add up, they have to add up to 180 as well. So, yeah, similar tricks, you just have to subtract from 180 a lot. Okay, on 16 through 21, this is more like the worksheet from Wednesday, but it's, we'll do this for our last section today. So what are the, how many were there? 5 ways we can prove triangles are congruent. Side, side, side.
No, that's not one.
Okay,
Angle side.
No one's helping me out here.
HL.
hypotenusally. Yeah, that was the last one. So what are the ones that don't work? Maybe we should mention those.
Side, side,
Okay, the bad word,
y'all.
and
Or side.
you guys know the other one? Like
Angle.
angle. Okay, so pretty much everything but those. Side angle does work on right triangles, but we call it hypotenusely. So basically anything but these is okay. All right,
Why doesn't angle work again?
because of this. If I drew it right,
Right, yeah.
all these are the same, but they're not the congruent triangles. Okay, oh yeah, we're, okay. 17 looks kind of like this. Mess. A, B, C, D. Alright, so, are these triangles congruent? Oh, let me ask this first. What is congruent that they're not telling us is congruent?
The middle line.
The line down the middle. This line is congruent to itself because it's in both triangles. So, how do I know these two triangles are congruent? What do we have here? Side. So, that's the first answer. If the triangles are congruent, we're supposed to make a congruent statement. You guys remember the book's version of this? So we're supposed to say like triangle ADB is congruent to triangle. Okay, notice these triangles are like turned around. Like this is over here, so this triangle is like this one turned around. Right? So if I start with A on this triangle, what should I start with on this triangle? B. A on this triangle is like B on that triangle. D on this triangle is like C. And then the last letter is B. B on this triangle is like A on this triangle. Okay, on 19, do we have enough info to say those two triangles are congruent?
No.
No. All we have is angle, 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 and that doesn't count. So we're not gonna put no, though, like the worksheet, because they said, if it's not congruent, you gotta list a fact that would make it congruent. So if they give us like angle, 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 we need at least one side, right? If you have a side, then you have at least angle, side, angle, or angle, angle, side. So what's one side that could be congruent? Like ST and, what's ST? WV, VW, whatever. Yeah, that would make the triangles congruent. Okay, I'm gonna help you guys a little bit on 20, not all the way to the end, but on 20 they don't mark anything congruent, but they do say in the directions that the lines are parallel. These lines are parallel, and these lines are parallel. So what do we know if the lines are parallel? Okay, when lines are parallel, these angles right here are called alternate interior angles. So if the top and bottom line are parallel, these two would be alternate interior, those would be congruent. And similarly, if these two lines are parallel, like these two lines are parallel, these are alternate interior angles. So these two would be congruent. And what else is congruent in this picture that I didn't mark?
The middle line.
The middle line. Okay, now that's where I'm stopping. All right, 21. All right, on 21 it says that AB and CD bisect each other. What does that mean? Bisect means they're cutting each other in half. So if they're cutting each other in half, E is like in the middle of this and of this. It's the midpoint of those two. So that means this would be the same as this, and that would be the same as that. What else is the same that I didn't mark? What? No, we don't know parallel lines on this one. Huh? Somebody said it, I think. Oh, great. I think my arm here like touches it or something. Is that it? My arm hair is a hazard.
No, that is.
Nope, I think that was the other class actually. Boink. There it is. No, wait. Oh, there's the one I lost.
So now go down a little bit.
No, it's on a different page. There it is, okay.
The angles,
Okay, which angles?
the vertical.
Vertical angles. Always the same. Okay, so what do we have here? We have boom, boom, boom. What's that?
Side angle side.
Side angle side. Luke's back in it.
Go, Luke.
What? No.
Okay, so then we have to make a congruent statement. So triangle ACE is congruent to triangle, so now notice just kind of like this on this triangle is over here on this triangle, so these triangles are twisted. It's a twisted bow tie. So A on this triangle matches what on the other triangle?
B.
B. B stands for booyah.
Over.
Okay, C on this triangle matches
D. As in dog.
Or.
It's cause Brian's not here. You fill in the
Like,
back.
You don't very encourage me.
You can do it, Brooke.
You should be on the Wendy's billboard.
Not that.
If you put my face on the Wendy's billboard, I'm gonna be so mad at you. I mean,
That would be
We should do that.
pretty
stop laughing about it.
See, you're right.
Sit down and you can work.
Just keep the
My face.
pigtails in the picture and just put
Just get a
it.
big
Face
poster
on top.
of Brooke's face and just put it on the billboard.
I mean, at least, a lot of people would see your face. I don't want people to see my face. I don't want you about it now. It'll ruin my reputation.
Brian's gonna be so proud of me.
People,
I don't know if I want his.
I was imagining Brooke's face on the sign and then I thought, what if AJ's face was up there?
Nah, he'd be on McDonald's.
yeah,
He'd be on the what?
McDonald's.